Hi y'all, this is a video on solving quadratic equations. We have a few different tricks we can use to solve quadratics. We can try setting equations equal to 0 and factoring. We can try using square roots to get rid of second powers. We have the quadratic formula if we run into something that we can't nicely use one of those other two methods for. So let's check out this one. I would say, unless it immediately jumps out at you that square roots are going to be a good choice, and I will show you an example of that, trying to set equations equal to 0 and factor is a really good first step with quadratics. If it's not factorable, we can then go for the quadratic formula, but if it is factorable, that tends to be the easiest method for people to get through. So in this case, we actually have something factored, but it doesn't help us out because the product is not equal to 0, it's equal to -4. It's really helpful to say that a product is equal to 0 because the only way to multiply two numbers and get 0 is if one of the two things that you are multiplying were 0 already. Not nearly so helpful to say that the product of two numbers is -4 because there are actually infinitely many combinations of numbers that you could multiply to get -4. Okay, so if we want to multiply this thing out so that we can then move the 4 over and set everything equal to 0, we're going to go ahead and FOIL. We're going to get a 3b squared plus 6b minus b minus 2, and that's still equal to -4. We can combine some like terms, always cleaning up any mess as we go. And then we can go ahead and add 4 to both sides of the equation in order to set it equal to 0. So we'll end up with a 3b squared plus 5b plus 2 equals 0. Okay, now that we've got the 0 on the right-hand side, it is useful to try and get this factored. So we'll try and break it back up. First two terms need to have a product of 3b squared. So I'm going to go ahead and make this a 3b and a b. You could choose the opposite order with that leading coefficient of 3. We don't have a lot of choices. We got a 1 and a 3 that are factors of 3, and that's about it. But you do have an order choice, and it's just fine if you choose the opposite order. For the last two terms, we actually have to check on two things. One, we need the product to be 2. The other one, which is a little trickier, is we want to split up those factors of 2 in a way that makes our outside inside sum to 5b. So I can choose a 1 and a 2 or a 2 and a 1, and I can also decide whether I want those to both be positive or both be negative just based on the fact that their product should be positive 2. So I'm going to go ahead and choose a 2 and a 1. If we choose a 2 and a 1, we have to make sure that we really did get our outside inside to add up to 5b. So in this case, the outside would be 3b, the inside would be 2b, and that does add up to 5b. So plus 1 plus 2 looks perfect. If you check that outside inside and it did not add up to 5b, I would try flip-flopping them. Do 1 and 2 instead of 2 and 1. Once you get it factored, we get to go back to this idea that if the product of two numbers is 0, then one of those numbers has to be 0. So either 3b plus 2 was equal to 0 or b plus 1 is equal to 0. If you can go straight from factored form to what the answers to the equations are going to be, I'm completely fine with that. I don't need to see these last couple of steps, but I want to make sure I show them in case anybody isn't super clear on what happens. Okay, so now we've split our quadratic equation into two simpler equations, two linear equations. And in both of those, I have a single b on one side of the equation, so it boils down to reverse order of operations. If I were to pick a number to replace b with, the first thing I would do is multiply it by 3, and then I would add 2. I want to go backwards order, so the first thing I need to get rid of is the 2, and then I'll work on getting rid of the 3. Because the 2 is attached by addition, I'm going to subtract 2 from both sides of the equation, leaving me with 3b equals -2. Now I need to get rid of the 3, which is attached by multiplication, so I'm going to divide both sides by 3, and I'll get b equals -2/3. I also need to figure out what solution I get from the second equation. Here I only have to get rid of the plus 1, so I'm going to subtract 1 from both sides of the equation. And I get 2 possible solutions. Again, it is great to plug these answers back in and double check to make sure you didn't make any mistakes, but I want to be really clear that a quadratic equation will never have an extraneous solution. There's no step that we did along the way that could introduce an extra solution that's not actually valid. So if one of your answers doesn't check out, you either made a mistake in solving or you made a mistake in checking, and you should go back and figure out what it is. All right, that's it for this one. Thanks.